Hello YouTube, this is Frank, and this is April 29th, 2026, and this is my 105th video and my 7th video in the chrony GPS to chrony series. And today's topic is a hand parser and flex byacc parser. And this is 7 out of 20. My project, it replaces the GPSD. My project writes to the shared memory, and that is going into feeding chrony. And today, the kind of an outline. I'm going to talk about the constraints of my program, my project. Time T is 64 bits. No leap seconds. I'm not going to consider leap seconds. And I want to kind of get clear on the 1024 rollover for those satellites, those GPS satellites, and then talk about the hand parser, and last talk about the flex and byacc. So I'm going to take my board down, and I'll show you what I got. Let's see. I'll put my board down. Let's see. Right, let's see. Disclosure, I have no financial, employment, personal, or family relationship with any brand or product. I purchase products that appear in my videos with my money. I'm retired. I put her around. AI was not used in this video. Video summary. Let's see. Video summary. We'll capture some GPS data from the GPS receiver, write a parser, and a hand parser and a flex byacc parser, and write some test data for that for those parsers. Now, definition, when I talk about byacc, now I'm talking about that byacc written by Robert Corbett, and that kind of involves finding that code and compiling the byacc from the old C source code. Berkeley 1.8, that's at the University of Utah, and byacc 1.9 is at the University of California at Berkeley. References. There's some references. Now, my knowledge of GPS is kind of limited. I don't claim any more knowledge. Well, the limit of my knowledge is the MOOC on YouTube. That's what I'm saying. I'm just a dum-dum. Now, let's see. Now, heads up. I kind of, I want to tell you about the next two videos that I make. I kind of went down a rabbit hole, and I updated and compiled the C source code from Robert Corbett, and now I like the original byacc, and now after this rabbit hole that I went down, I'll be back on syllabus at number 8, and that's a fuzzer. We want to fuzz the inputs, our parser project. Let's see, this is where we are in my project. Let me just show you where we are. The last video was Valgrind, and I kind of messed up a little bit. This video is the parser for that recommended minimum sentences from NMEA. I went down a rabbit hole with byacc, and I'm going to make a video on byacc if you're interested. If you're not interested, you don't got to watch it. And then we'll be back on track with the fuzzer on video 8. And these are kind of what I've got planned going on. with my project. All right. Yeah, that's now when I talk about Berkeley YAC, I'm talking about the original Berkeley YAC written by Robert Horwitz. Now I used Berkeley YAC at work for about 20 years. There were there were dozens of instruments and dozens of formats that I used, Lex and YAC. Now I'll just show you a quick view if you want to see what Lex and YAC look like. I'll show you a quick view of that. Now there is a learning curve for Lex and YAC, so if I wanted to parse a lot of sentences, it would be worthwhile to take a look at the Lex and YAC. Now another thing is if you're interested in looking at some computer science, parsing a simple language, those sentences are easy to parse into tokens and recognizing grammars. Now, if I wanted to look at every symbol in a stream or file, I would probably want to look at YAC, Lex and YAC. I used to do a lot of data checks on those various fields between sentences, and I would probably want to look closely at Lex and YAC if I wanted to do that. Now, if I were just wanted a quick parser to parse those sentences and hand them up there to chrony, I would probably just go with a hand parser. So, and a short version. Let me just kind of, before I get too far into the video and lose you, let me just kind of show you what I'm talking about. This is a hand parser, and I've got it. Let me see if I think I've got it. Let's see if I right here, the hand parser. Let me show you what I got. I've got a make file right there, and the hand parser, and we'll just compile that. I think it's make clean. I'm just going to clean, make sure we start clean, and make it. All right, and I just kind of want to bring this to your attention. I'm using those JPL and Airbus flags. I just kind of wanted to bring that to your attention, and it's just let's see what we got here. There's my executable, and it's hand parser, and I've got a one sample file right there, simple one, and it's pretty quickly. Let me do that. Let me pipe that into less right there. Just kind of show you what I'm doing. There's that sentence there that I'm talking about, the required minimum. There's a time, and then over here there's a date. And so I'm just parsing that into the time and date, and that's the UTC time right there. That's what kind of what we're doing. And if it can't see right there, if it's not an RMC line, it skips it. So it's going to skip everything until it finds an RMC line. Let's see now. Have we got one coming up here? Here's one right here. See, so it's going to skip all those lines there from our GPS sentences. So it'll be fairly quick. But I kind of want to bring that to your attention. Let's see. Let me get back to my notes, and I'll show you. Let me show you what the Lex and yeah, if you've never seen those, I kind of want to bring that to your attention. And I believe it's this one right here. I've got the main program, the make file, and then there's the lecture, and that's the YAC grammar rules. So let me compile that. Let's see, that's make file, make, and let's just do a clean, and now let's do a compile it. All right, so we've got this now. I kind of want to bring this to your attention. I've got it using those JPL and Airbus flags, and there's a few things that some of those warnings I could not get out. That's the Lexer from Flex, and there's some warnings there that I can't get out of that. But they're fine though. I mean they're not errors. So let me kind of show you what I got. So if we see right there, there's our executable parse GPS. Parse, and I'm going to do that first file right here. Now I'm going to let me kind of back up just a hair. I'm at the lecture. Let me well, hold on just a minute. Let me back up just a hair. Let me see where I am on my notes. The tokens. I'm at the tokens. I'm looking at tokens right here. So the lecture. The lecture is looking at that input stream. Let me just kind of show you what I'm talking about. That file, the input file. So here's my GPS sentences right here, and what I'm doing is breaking up these sentences into tokens, and that's what the lecture is doing. So let me get out of this right here, and I'm going to parse that. Let me paint that into less. Kind of show you what I'm talking about here. Okay, here's the sentence that I'm parsing right here. That this Lex is looking at, and see right here, the token right there. The token. Then it sees a comma, and then the time, another comma, uppercase. Let me kind of scroll on down here. See, there's the checksum, uppercase A, the comma, see comma. Then there's a time field, another comma, and then a floating number, comma. That's what the lecture does, is it's breaking up these sentences into tokens, strings. See, there's strings, and then they're deciding on what kind of tokens those are. So let me just kind of scroll on down here. And all of those sentences are going to be broken down into tokens and strings, whatever that. See, that a comma is a token comma is a comma, is what I'm saying right there. There's that. See, there's a bunch of empty fields right there in that sentence. So let me get out of here. Let me get back to my notes. Show the okay. Now that's the lecture. The lecture breaks the stream up into tokens, and then the YAC. Oops. I wonder if I can undo that. All right, let me, I must have messed up there with my highlighting. Now, just a quick thing before I move on to my yak. Let me just kind of show you what I got right here. My lecture. Let's just kind of show you what I got. If you've never seen the Alexa, I always, let me just kind of back up just there. Now, whenever I write a Lex program, I always put some sample data in there to kind of show me what I'm trying to parse right there, scan. And you just kind of, let me kind of move on down a little bit here. Now, this is the rule. See, I'm looking for these patterns, and I'm going to kind of label these. So there's my required minimum ID right there, and I've got several IDs. And the arrow right there, the up arrow, that's the beginning of the line. And I've got various things here. The time, the various time ways to display the time. Now, with Lex, the rules that there are now if there are now Lex matches everything it wants. So, but the longest pattern wins, and the first rule wins. So if there's like a time here, if it would match, say, an integer, there would be like the same size as an integer, but since the time one is listed first, the time one token it wins. Same thing with like a floating point. So I've got a floating point right here for time 2. If I had a floating point number that could either match time 2 or a floating point, break that down just a little bit right here, like that right there, the time 2 would win. And so what I'm talking about is down here where I'm listing my rules down here for Lex. Let me just kind of move on down a little bit. So each one of these rules that I've got listed, if it matches that pattern wins. And so here's time 1 right here. I wanted to get down to time 1. And the last thing I do is return the time 1 token. Now I do return the text of that. So anyway, let me get out of that. I just kind of wanted to show you that a little bit. Now, let me get back to my notes. Tokens. The next one is YAC. If you've never seen YAC, let me show you that. I should have a. Wonder how come it don't show me my. Oh, there we go. Let me see where am I at right here. Let me just back up. I'm going to get back up a directory. And I think I've got it. Yeah, there it is right there. Show my YAC sentences. It's kind of the same thing. Let me clear this right here. Here's my main, my lecture, my YAC, and there's my make file, and I'm going to use that sample input file right here, and it's just make and clean, make sure it's clean, and then let's make it, and let's run that parser. This one I'm kind of showing you the how the grammar recognizer works right here. F1. Oops, let's just not less. Yeah, now this is the YAC. Now what it is doing is taking those tokens and trying to match the tokens into a sentence right here. Now let me kind of show you what that looks like. Let's do a less on that. Oops. This is YAC right here. So I still got I usually put some sample data in there to kind of show what my lecture is looking at, my YAC is, my grammar is looking for. And so my grammar, these are my tokens that I recognize, my tokens, and then these are my sentences that I recognize. And so like my RMC line, that sentence has an RMC expression, a comma expression, time expression, comma expression, good time expression. So it has to match all of those expressions before it recognizes the sentence. And if it does not recognize that sentence, well, it panics, and we can just say there's an error in there. There's an error in that sentence. It prints an error. Now you can print out whatever error messages that you want, and you can get as detailed as you want to. Now I'm going to, let me just get out of here. Let me just show you one more thing right here. Those expressions, let me kind of get down one more right here. Yes, these are all sentences. Let me kind of show you see right here, that RMC expression that just recognizes a token is what that expression is. So that's the RMC expression, and a text expression, just the text. So what I'm trying to say here is, let me get back up here to the top. The data stream, it can be any number of these sentences in any order, and then a sentence has these expressions, and that these expressions must be recognized in this order, and the expressions are tokens, and so it kind of you have to match all the tokens and the strings to the sentence. Well, let me just hold on just a second. Let me see what there's back, I guess 20 years ago, I used that book, Lex and Yak. They can explain it a little better than I can. Anyway, let me get out of here. Let me get back to my notes. Let me see where I'm at. introduction. Yeah, let me show you. Now, what I'm doing is I've got these micro PCs that I bought, and I've got they were $55 refurbished PCs, and I've got see this right here, this little thumb drive, that little thumb GPS receiver. I've got that, and I want that because I want a signal that's kind of intermittent right here. See an intermittent signal, and I want to feed that to chrony because chrony is kind of this designed to work well with those intermittent signals. See, with the wide range of signals, and so I kind of want to play with that. That's the reason why I'm using that little this thumb drive. I want to get an intermittent signal. Let me show you where am I at here. Where am I at? Yeah. I just kind of want to play around with those various settings, because when I look at GPSD and ntpsec, I don't think they allow testing of different combinations of time and position status. So that's what I'm looking at. That's why that's kind of the whole purpose of my project, and because I wonder if there's a significant difference between the fixes, like a none, 2D fix, and a 3D fix. And when I was watching those Stanford GPS videos, the professor was saying there's 4 equations and 4 unknowns, and when the receiver gets a 3D fix, it does not have to find that time variable again. Now I'm a dum-dum. Now I'm just going to show you the equation that they're talking about. This is on page. This is that. I think it's Navy or Coast Guard publication, and I think it's page 27. Yeah. Oops. Let me scroll down here a little bit. Yeah, these are those 4 equations that he's talking about. And the CB, see that CB right there? That's that clock bias for the user. And I think what he was saying is once they get a 3D fix, they don't have to, the receiver does not have to calculate that user clock bias again. So I want to just play around with that. And now with GPSD and ntpsec, I don't think they'll let me do that. Yeah, so let me get back to my notes right here. Yeah, there's those equations that. Yeah, see now, from what I understand, there's just no way to look at a lot of these things. I mean, we're talking about milliseconds or microseconds, nanoseconds. I don't know. And see, the whole purpose of my project is to use those inexpensive GPS receivers for timing. And let me get back here. Where am I at here? Yeah. Now, another thing, now just quickly, I just want to kind of bring this to your attention. Now this is from NASA, from one of the NASA guys right here. Now I believe it's page, I think it's page 23 that I want to go to. See now, over the standard signal that they're talking about, standard signal performance. See, over time, it's they've gotten much better, And see, the satellites have gotten better. Let me back up just up here. I kind of wanted to show that chart right here. See, the receivers are getting better. The satellites, see, the satellites are getting better. Increased accuracy, integrity, lifetime design. And see, that's 2014 to 2025. So I kind of wanted to, kind of show you that because, I mean, the receivers and the satellites are improving, continuously. And so, I kind of want to play around with these receivers. Yeah, there's Flex and Yak. Kind of, yeah. Right now, I might just look at the, well, I might be able to, now that I have, several of these refurbished micro PCs, I might be able to put a hand parser on one and a YAC parser on another one. So that might be something I want to look at. But probably right now, I mean, I know I don't want to do the pulse per second right now. That's too hard for me at this time. Other than that, let's get kind of clear on these epochs and rollovers. Now, let me just kind of show you. Now, there's the National Geodetic Survey. Now, they have a web page where they kind of show you the GPS week number right here. And let's kind of scroll down a little bit. And we're kind of right here. This is kind of recording right here, 11:41 at night right here. So it's kind of showing May. But anyway, it shows the week number. Let's see, the day of the month and then the day of the year. And that's kind of useful looking to see what kind of what the year number is for those GPS. See the GPS calendar shows the week number for those GPSs. So let me get back to my notes. Kind of wanted to bring that to your attention. All right, so that's the National Geodetic Survey thing. Now the current year is 2026. Now I made me a timeline right here, and 1900. That's kind of the year I was looking at, and then the year 2000. See, that's 100 years between 1900 and 2000, and so we're at year sometime T. And this year, see, this is Frank. I'm right here at 2026 at time T. And so there's 100 years there. So I'm at 100 years plus T is what I'm saying. Now there's now the C language, it has a time structure. And you'll see in my programs, I call it blob. There's a blob of days and times and dates in there, and that starts at 0 is 1900. Now, Unix, UTC, chrony, and time T, they start 0 in 1970. Now, the GPS satellites, they start 0 in 1980, and that's WN is week number. You'll see that in those publications. WN, that's week number, and that continuously increases. But the thing is about those satellites is that it only transfers 10 bits of the week number. So at 1024, it rolls over to 0 again. So there's a 0 here at the start, and 0 here, and a 0 there. It's kind of like counting by 10, like the decimal system. So I've got 0 to 9, And then when I go to 10, well, you can see the digits here, you know, they start 0 again, 0 up to 19, but see they've got a 1 here, kind of similar to that. And then when I go over to 20, you know, I've already got these two, you know, 0 to 19, and then kind of the 20. That's kind of what it's doing. It's actually modulo 1024 is what it's doing. Now there are no satellites. I want you to see. There's the first satellite in 1980. Now I want you to. There were no satellites in 1926. So if I've got a 2-year, if I've got let me get out a little bit right here. So if I've got a 2-year date right here, I mean, there's no way I'm going to be able to. I'm not going to confuse 2026 with 1926. There were no satellites here, so it has to be 2026. Yeah, see, there's no GPS satellites in 1926, so it's got to be 2026. There's modulo 1024. Those are those weak rollovers. Yeah, let's just capture some data on the thumb for those GPS receivers by the hand parser. I kind of showed you that hand parser, and I kind of showed you the flex and yak parser. Now, I did capture 3 days of output from from these thumb drive. Now, if you want to be more thorough, you need to capture several days. I would recommend several days of output from those receivers, because there's a lot of things that can happen, and I'll show you what I'm talking about. There may be some garbled data in there. That's what I'm kind of saying. Now I mentioned constraints. Let me kind of show you in my introduction. I kind of mentioned constraints. Now I'm saying time T is 64 bits. That 32-bit it wraps in 2038, and that's kind of coming up. Now that wrap issue, it's too complicated. I'm gonna tell you what, it's too complicated for me. So I am assuming. Let me just kind of, if you go to the year 2038 problem in Wikipedia, now they can kind of explain that problem. It's just too hard for me. There's just all kinds of problems with that. There's file systems, databases, operating systems. So see what I'm saying? It's too hard for me to. I can't deal with it. It's when I'm a dumb. I can't deal with it. So I'm just going to say, I'm just assuming time T is 64 bits. Now that shared memory in chrony is time T. So let me just kind of show you what I'm talking about. This is that structure, the shared memory structure, and now when we hand our time T over to chrony, so I'm assuming that these time T values are those fields are 64 bits. 64-bit fields right there. Now for leap seconds, kind of the same thing. If you kind of go to the leap second in Wikipedia, there's a whole bunch of things wrong. Going on with leap seconds. I'll let you let me just kind of show you this right quickly. These are the leap seconds. Now, just kind of want to bring this to your attention. See, now there's been no leap seconds for almost 10 years. I want to bring that to your attention because there have been a lot of software, there have been a lot of hardware that there's a lot of software that has been written, a lot of hardware that's been produced there in the last 10 years, and I don't know how thoroughly that has been tested. And if you kind of want to look at the other problems, let me just, I think they have it down here. Problems with I mean, I mean, when you get to looking at it closely, it's just something I don't want to deal with. I want to bring that to your attention now. I'm just not going to, there's just too many problems, you know, and even they're talking about a negative leap second. So, no, I mean, I don't want to deal with it. I will be using the 64-bit time T and UTC, and these are the C functions that I'll be using: time GM and GM time. Now, time GM, that is a new function in C, and that's in the C23 standard. Let's see now. These are for UTC, and these functions in C. They're for local time. Now I'll be using those time GM and GM time. Now I am not exactly clear how chrony handles those leap seconds. And Red Hat, they have a couple of web pages. They've got 5 different ways to handle leap seconds, and then there's another one right there. Now I'm just gonna ignore leap seconds and just use whatever default algorithm is in chrony. It's gonna, I believe that's the easiest. And then I'm just using consumer grade equipment, so I'm just ignoring them and let whatever the default is, whatever the default for chrony. Programs written in C and Flex and Berkeley YAC. I'll be using the knowledge from my exercise I did with common weaknesses for my compilers. The stubborn weaknesses and the top 25. I've got, I mean, there's the stubborn weaknesses, and if it's on this list, I mean, I've got to take care of that in my code. If it's a stubborn weakness, we'll do that. If it's a top 25, we'll see if we can make sure we don't do any of that. I've made those mistakes over and over. I mean, I'm just tired of making these same mistakes over and over, and I can't make the same mistakes that are in the stubborn weaknesses or in the top 25. So we'll see if we can try to take care of that. We'll accept those NMEA sentences. Now I think that C right there, I think there was an A, B, and a C, and I think they're on the C right now for that recommended minimum. And that's what it kind of looks like right here, where the hours, minutes, and seconds, and the position code right there, and then the date is over here. And that checksum is at the very end right there. Now this is kind of what I was thinking about maybe in the future. See that GSA that has a field right there for 1 for no fix, 2 for 2D fix, and 3 for 3D fix. And there's several states in those GPS receivers. No signal acquisition, 2D, 3D tracking, others. And you know, I wonder if, you know, if time is going to be, once it finds that, once it gets a 3D fix, I wonder if it will be okay to accept no fix or 2D fix. I kind of wonder what that is. How if they're what the error range is what I'm saying. Accept the time and dates, hours. We'll only accept valid hours, minutes, and seconds. Accept only valid days, months, and years. Do not accept leap seconds. And we'll only accept the top of the second. Like if it only shows hours, minutes, and seconds, or hours, minutes, and seconds and fractions of a second, we'll only accept the top of the second, 00. Valid date. So like February the 31st, that is not acceptable. We will not accept February the 31st. So if a date looks like this, the 31st of February, we will not accept that. Leap seconds, that might be what a leap second looks like. We will not accept leap seconds. Hardware. I'm just interested in those inexpensive ViewBox receivers on the Amazon. I did find an eTrex the Garmin eTrex that I've got. I'll show you that. And I did find one of my old GPS mouses that I used for mapping about 12, 15 years ago. Now, now I want to tell you now. Now, back when I was trying to set up those networks, those isolated networks, I had a job, and I was not able to really single step or go through those the documentation thoroughly. But now I'm retired and I have time, and I'll kind of show you what I'm talking about. Now, those weeks, those 1024 weeks, now we can calculate the number of seconds in two different ways. One is unit conversion. I have 1024 weeks times 7 days, 24 hours, 60 minutes, and I get 619 million seconds that way. Now, the Coast Guard, they have a site. Let me kind of show you the site that I'm talking about right here. Let's see, this is it right here. And they give you some information on the GPS week rollover number, and they give you the dates right here. So like that was one rollover, and then in 2019 there was another rollover. So if we were to take the midnight from this rollover and that rollover, we should calculate the same 619 million seconds. See, that's what I'm saying. If we were to put those dates into the time blob, see, there's the begin and the end, and if we were to subtract the end from the begin, we should get 619 million seconds. So, and I've got a program right here. Let me kind of show you what I'm talking about. Let me guess, GCC rollover. So yeah, so there's, see that week 0, August 22nd, and then April the 2nd right here. See, let me show you that right there, kind of right here. See, that's what I'm doing. How many seconds are between those dates at midnight? And that's what this program was doing. So can we get the same? Can we get the same number of seconds? So let me get out of here and do that. And I'm going to pipe that to less. Yeah. See right here? August the 22nd. April the thing right here. So I get the same number. N minus the begin. 619 million seconds. And then calculating it the conversion way, I get the same answer. So I'm pretty confident. See, that we got the same. There's that many seconds. There's that many seconds in each epoch. Now I'm going to tell you. Now I'm not very smart, but I just cannot understand that NTP documentation or the GPSD. It just makes no sense to me. Let me just kind of show you. It makes no sense to me. They're talking about that wraparound thing right here. Trashed. You cannot expect a recovery from a trashed system clock. Now, this makes no sense to me. This makes no sense. Let me kind of show you what I'm talking about. See this right here? Now this is a single board computer. Let me get my pointer right here. This is a single board computer. There's no real-time clock on here. Every time the power goes out, the system clock is trashed. Now I've got that receiver, that GPS receiver here, and so when the receiver gets the satellite fix, we'll get the correct. Well, we'll get the time, the GPS time. But this makes no sense. This makes no sense right here. Now let me kind of show you what I'm talking about. Now let me put this down. Yeah, and I was just talking about there's no real-time clock here, and let me show you what I'm talking about. Let's see now. Yeah, now I've had this an isolated network for 6 years. I had a single board computer with the GPS mouse, and I've got a work monitor. I've got a table on my. I've got a monitor on my work table, and that the time is correct every time I look at it. And this right here, let me show you this. This makes no sense. This makes no sense to me. Let me show you what I'm talking about. Here's their web page right here. There's that the caveat that I was talking about, the trashed system clock. Then if you kind of go down a little bit more, let's see now. Is it at the bottom? Maybe at the bottom. Yeah, this is where they're talking about the 24 weeks. This makes no sense to me. This makes no sense. See right here, it says the problem is fundamental and cannot be compensated for in the code without relying on the accuracy of the local system clock. This makes no sense. No sense. This makes no sense. This makes no sense. Let me kind of, now I have a one-line workaround for older GPS receivers. At no time do I look at the system clock. So, see, oops, where am I at right here? Yeah, so this, it makes no sense. Let me get back up here to where I was. Now, the only remedy is this makes no sense. This makes no sense to me. See right here, the only remedy is not to use ancient GPS hardware. This makes no sense. And let me kind of show you. Now U-blocks, and that's the people that are making these, what I'm talking about, these receivers, U-blocks, these receivers right here. Now U-blocks, if you read their documentation, they recommend that you read the time and date as usual, and then correct the date before you pass the date up to other programs like chrony or NTP. And they have the U-blocks documentation. They show that they have a table with various receivers. Let me just, and this is more that this makes no sense right here. Let me just show these the clock. See the clock reference drivers. If we go over to GPSD, and I believe it's kind of down here at the bottom. Yeah, known bugs. This makes no sense. See right here. I mean, if I was a manufacturer, I wonder if I could sue these people right here, because it is documented. I mean, they said it's almost never documented and not safe to bet on. Well, U-blocks, they do have a publication, and I'll show you that what I'm talking about. I mean, this makes no sense to me. Let me just hold on just a second. Yeah, and this makes no sense. You just add, all you have to do is add the 619 million seconds to time t. It's simple. That's all you got to do. See that many single board computers, they have no real-time clock. So every time the power goes off, your clock is trashed. It makes no sense. Now let me just kind of show you this right here. Now I'm going to blank this out right here. Now let me show you what I'm talking about. Now, and I said I did find my old Garmin E-Trex that I used on my bicycle. I used it about 20 years ago, and so let me just kind of show you now. So this is an isolated system right here. This is an isolated receiver with a GPS receiver, single board computer. This is an isolated system right here. There's no network connection at all to it. It's an old GPS receiver. So if I turn the thing on, now I'm going to pause the video while it acquires the satellites. I see it's coming up right here. I don't know if you can see that, but let me hold on while I'm going to pause the video while it comes up. All right, I've got my Garmin. It came back up. It acquired the satellites. You really can't see them. You really can't see the time, the time and date there. So it's the day is the 14th, September 14th, 2006. So I'm going to put that in. I put that into my time blob right there, and so if we were to add 619 million seconds, we should get April the 30th. That's right now. I mean, look, see right here. Look at my. Can you see that time there on this computer? I wonder if I should I be able. Let me blow that up right over here. Does it say the time? It says the 30th. I thought it was supposed to say that. You can't really see it very well, but it's well, it's the 30th, April the 30th. So I mean, you really can't see the. So I just put 12 right there for the hour. So if we were to go back over here to my rollover, let me show you. And go down to the bottom. See right here? The 12, I can't read the time, but it's September the 14th, 2006. And if we were just to add 619 million seconds, we should get April the 30th. So let's quit here. And GCC, oops, roll over, and A dot out. See right here, September 14th, 2006. We just add that rollover. See right there, Thursday, April the 30th. 2026. See right there, that's my old E-Trex from that old, from the previous rollover period. So let me get back to my notes. Let me show you what I'm talking about. See this, my E-Trex, let me get over here. See, my E-Trex, it's stuck over here in between 2000 and 2020 right here. It's stuck in between there. But the time is 2026. The year is 2026. Well, it's April the 30th, 2026, and it was saying September. So see, it was stuck in this partition, and we want to go over to the next partition, and the only thing we need to do is add 1024 weeks to that. So and I just kind of showed you. It's simple. This previous rollover period, I want to go to the next rollover period, so you just add 619 million seconds, and there you go. Now, I don't know how to smoothly handle the day of the rollback. I don't know how to do that. I don't have an algorithm, but that's 20 years though. That's almost 20 years between the zeros. So see what I'm saying? every time the power goes out, the system clock is trashed on those single board computers. And as far as the 1024 rollover, I mean, uBlocks has their own workaround, and I've got mine. I just got those things where you just add 1024 weeks. Yeah, see, it's simple. It's called addition. I don't know what those people are, you know, what's wrong with those people is what I'm saying. You know, this whole thing right here, I don't understand it. Let me get back to my notes right here. I mean, I wanted to bring that to your attention because now that I'm retired, I can look at it and kind of figure out what the issues are. Yeah, so these week numbers, the modulo 1024, that satellite, it only sends up 10 bits. So it's modulo, the week numbers are a modulo 1024. So they start back over, you know, kind of like the decimal system, like 0 to 10, 10 to 20, 10 to 30, 20 to 30. It's not that hard, in my opinion. It's simple. Yeah, let me just tell you, I mean, if we're in this partition and the time is over here and we want to go to the next partition, you just add the 619 million seconds to time t. It's just arithmetic. I don't understand what they're talking about. It's just arithmetic. I learned how to do conversion in the 7th grade. You know, I'm just kind of getting, well, I don't understand these people. All right, let me skip down here now. I wonder where I'm at right here. Oh, let me just kind of show you this too. So if I've got the my uBlocks receiver right here, I've got my receiver, and I capture that video, those sentences when it first comes up. Now there is a date in the ROM code right there, but that's not the date now that for the rollover. It's in the publication. You have to look in the table in that uBlocks publication. You cannot go by you cannot go by that date. It's in the publication. It's June for this particular receiver, it's June the 3rd, 2012, and then the rollover is 2032. So I've got 6 years before it rolls over. Yeah, it makes no sense. It makes no sense to me. Yeah, now if you want to find the uBlocks documentation, just search for the GPS roll number for uBlocks. Now, in this project, I will trust the uBlocks documentation. The GPS people, they give no examples where the rollover date by uBlocks is incorrect. Let me just kind of show you this right here. Let's see, where are they talking about this? Yeah, see right here? This is almost never documented in a safe bet. I mean, they give no no documentation for that statement. You know, if I was U-Blocks, I might wonder if I could sue those people for that. Oh, and then we get back here. So I showed my my Garmin, my old Garmin. Now, it is, you know, now when those manufacturers, when those manufacturers manufacture these receivers, now they're not always going to be right there in the manufacturer right there in the start of a partition. They might be in the middle of a partition, but I mean, same thing applies. So I mean, there's 24 weeks there if I want to get to the next partition. Yeah, you just don't, it's simple. You just add 24 weeks to get to the next partition. All right, let me see if I can see where I'm at. Oh yeah, now if I wanted to capture those sentences, well, we need to. I usually put that set the TTY into raw mode and turn the echo off. That's what I do, and then I can cat that device into a file, and then use that file to as input into my parsers. Now you can put set the device to raw and cat it all in the same line. I have done that, and I did this back in 2025. I'll show you. Started out with a brand new receiver, and I captured the output, and now I'm just listing the RMC sentences. See there, it starts out, then it gets the time. It gets the time first, and then it goes down for a couple of minutes right here. See, then it gets the date. Then it goes on down, and then it gets the fix right here. So that's it kind of gets the acquiring satellites, and then it gets the time and the date, and then it gets the 3D fix. And I kind of wanted to show this file right here. Go open right here. See right here. With this thumb drive, and it's kind of sticking out it's under a window, but it's not out in the open, and so it kind of does lose the 3D fix intermittently. So you'll see it pick it back up. See right there, it picks back up and it loses it, and that's what I want. That's what I want. I want a receiver that. I want a receiver that has that intermittent signal, so I can kind of play around with those settings. So there it is again, kind of goes and comes. Because I want to play around with it. Anyway, let me get now. I'm gonna scoot on down. Yeah, this is I'm gonna probably have to. Yeah, let me move on down here. Captured it to a file. Yeah, just a sketch of my network. I've got fiber coming into a router. I'm over here on one of my i5 refurbished PCs. Right now, it's running Fedora 43. It was running Debian 13 Tweaksy, and I kind of didn't. I wanted to try Debian out, but I don't like it. I went to Fedora. I would recommend Fedora over Debian, for developers. The compilers are newer, all that development stuff. It's several years ahead of Debian, in my opinion. Now, for the GPS thing, I've got my GPS. It's over there in my workroom, and it's running Ubuntu. I do have some pulse per second GPSs over there for timing. Let me get back over here. This is kind of a sketch here. I'm looking at those inexpensive U-Blocks receivers. You'll see them. It's the TTY ACM. I don't see the, you'll see other you know, if they come up. I'm looking at the ACM, the CDC ACM receivers right now. Maybe later I may want to look at USB UARTs. I've got an old receiver that comes up. If you want to capture the data, you can list devices. I made a video earlier about this. I'm just going to kind of scoot on through this. If you need to look at the commands, I'm just going to kind of scroll on down. If you want to take a kind of quick look at the data and nothing works, you can try the sudo cat it, and you may be able to quickly look at your data. Otherwise, you got to add yourself to the groups, and you have to log off and log back on if to make those groups apply. They don't apply to the current section. Yeah, this is my commands right here. These commands right here, you kind of want to. That's what I'm using. You may see some instructions that have a speed parameter, but they usually, it does not have an effect on these ACM. Oops, let me just kind of, now I do find some useful and reliable information on the Raspberry Pi forums and the Arduino forums. The hand parser, I kind of showed it. Let me just kind of show you. I did not show you the flags. Let me, oops, where am I at right here? My hand parser, here's my hand parser. Let's see now. Now I did, for the JPL flags, I did JPL-C. I did kind of rename those to JPL-C, and kind of to bring that to your attention. The JPL coding standard, and it's kind of, I believe it's on page 8 of the JPL coding standard. Kind of go down to page 8. 6, 7, I think it's kind of at the bottom of, there it is, see bottom of page 8 right here. Those are the flags for, that's what I'm talking about for the JPL flags. Let me get back to my, those are the JPL flags, C flags. For Airbus, I call these Airbus C flags, and these are those from the Airbus Yeah, they have for GCC and C-Lane. You have a whole bunch of sanitizers, GCC there. See, did it get past it? I think they had C-Lane in here somewhere. Anyway, that's in here somewhere. So let me move on. Let's see now. That was the flags. I showed you the parser. Showed you how to make it. I showed that file at the very beginning of the video. Yeah, let me just take a few minutes here on Lex and YACC. Now I did. I worked at work. I used those for about 20 years, and there would be about 60 to 80 instruments, and they would record up to a dozen different sentences, and the sentences could have a dozen or more separated comma separated fields. Now I used Flex and YACC to verify the fields were in the domain, the checks. I used various checks among the sentences, the data fields. I did some simple statistics, and I wrote out I created some input files into the graphing programs. So it was very, very useful at work. Flex, that's the Elixir generator that scans the stream and breaks it into tokens. Now this right here, I do not convert those tokens into integers or floating point. Now you see that a lot in those tutorials. Let me just kind of show you what I'm talking about right here. I think I've got let me just kind of show you my lecture. Let me get down here to my these rules. I don't let me get down to a floaters, integers, or time or see. The only thing I do is copy those that text that matches the token into a pointer, and that's the only thing I do. I do not convert it over to any kind of floating point or integers. I wanted to bring this to your attention because you'll see this in those tutorials. If they've got an integer, they'll convert it over to integer and send that as over to the parser. But I do not do that. I kind of wanted to bring that to your attention. Let me get back to my notes. Yeah, now I only convert those strings to numeric whenever a calculation is needed. Otherwise, let me kind of show you why that is. I'm going to kind of show you why. Let me get out of here. Let me do the list. F1. Let me kind of show you now. I'm going to look for leading zeros. See right here? Look at all these leading zeros on these, on these, especially the integers right here. See, those are leading zeros on integers. And if I were to convert these strings into integers, I would lose that leading 0. It would just convert 0, 1 into 1, or 0, 2 into 2. But I want to know exactly what that parser, what that lecture is reading. And you'll see it throughout this file. I mean, this common, I mean, just all over the file right here. And that is the reason I do not convert those strings over to numeric. Yeah, those are. Yeah, I talked about the lecture. The first rule wins, the longest pattern wins. Yeah, so whichever pattern I want to win first, I list it first. If there are two patterns that can match it, I list the first one that I want to match first. Regular expressions, they're greedy. They match the first, then match the longest pattern. See right here. So if I had a string of numbers right here, that regular expression, it'll just match whatever the thing is, and however long that string of text of digits are. So I do not do this in my lecture. Put the limits on there, so like 1 to 8 digits, something like that. But yeah, it breaks the string into the tokens. It recognizes the grammar. When I first start with the lex and yak, I start with a simple file first. The only thing I do is recognize read the input, break it into tokens, and write an output file, and then I diff the input file and the output file. So let me just kind of show you what I'm talking about. Let me get back over here to my. So here's my parser right here. Let me, oops. And we'll make it. And let's just parse. I'm going to parse this file right here. All right, that's that my simple file that I'm trying to parse. Now, what I'm talking about is, see, if I parsed it, but what I want to do is put the output into a F1 out.txt file, and then I want to diff the F1 with the F1 out to make sure I'm reading the same exact input. I match it with the same exact output. Now I do write some kind of diagnostics right there on that that output file. Let me kind of show you that. I always like to write what file I'm parsing, and then down at the bottom, if it found any errors, and then I write end of processing. So it did not find any diffs. In the file that it was parsing. The only diffs that I found was my headers and my footer. So let me get back to my notes. Yeah, I want to verify that it can read all the symbols, recognize all the sentences. Yeah, let's get a simple file first. Now if we want to the simple file, if we want to do, I mean, if there are no errors in the input, there's no problems. But there's the problem is, now when I was working, I mean, with dozens of instruments and dozens of formats. Now, using Lex and YAC, it was it seemed to be easy to keep track of which format was used in which instrument and when the time changed. Now, you can also write output files to go into graphing software. Because with those graphical displays, those sometimes those sensors suddenly go bad, and other times they'll just gradually start drifting, out of range, out of their domain. Now, if I want to write an industrial strength Lex, and it needs to be able to parse everything. And now on this video, I captured the input for several days to show you to show you. On video 9, let me just kind of show you what I'm talking about. Let me get over here to my this one right here. I think it's and I'm gonna have to use my editor, and I'm gonna have to let me change the palette here. What I'm gonna do is I captured the data for about 3 days, and what I'm going to do is sort that data. Let's see, alternate block. See now here what I'm talking about. I mean, let me go here to the top. So there can be blank lines, partial lines. It kind of looks like you might have when you look at your file, most of the time it looks like good data. But if you look more closely at it, see here's the bottom of the file. I mean, there's like a partial ID right here. There's kind of mashed 2 lines together, and it cut off the front of this line. That looks like the checksum ID that it kind of messed up right here. Yeah, I mean, this. See what I'm talking about is I'm gonna get out of this. Is that it? You have to be able to read that garbled input. Now, let me just kind of show you one last thing here, and that's let me just kind of show you what I'm talking about. That's F2. That's what I'm talking about, F2 file. If I'm on, unless F2, oops, F2. Now I created this file my own self because I would see the various different kinds of sentences that I would see, and so there's just one line with $1 in it, one line with those checksums, various checksums. Now let me just kind of show you. See right here, where I'm looking at a sentence and I'm adding one character at a time to that sentence, and I want to make sure there's just one. Then I get that. Let me just kind of show you this. If I've got a sentence and I'm $GBRMC, those one letter at a time there, because you'll never know. And here, see right here, now I'm going back the other way. You never know how that data is going to come in. And this one, see, I'm looking at the time and the seconds right here. I only want to set except the top of the second. So I test all the way to 99. Then I test the, see there's that special character for the checksum. And start looking at the various checksums. And here's the dollar thing for the IDs. Commas. And this is the, when I look at the dates, make sure I only accept valid dates. Let me see here now. So there's February the 32nd, February the 30th, February 29th. Make sure I can accept only valid days, dates. So let me get at this. I mean, there's numerous data checks that we need to do to be able to accept any kind of garbled data. So let me get back to my notes right here. The next video is Berkeley YAC. I want to update and compile the original C source from Robert Corbett. And that's the end of this video. And I'll see you next time. The Berkeley YAC video. Thank you.